Alright, so in this question it says the diagram shows a metal part ABCD made from two parts. The part BCD is a semicircle, this one BCD is a semicircle. The part DAB is a segment of a circle with center O and radius 10 cm. This DAB, right, it is segment of a circle with the radius O and with the center O and radius 10 cm. Alright, angle BOD is 1.2. If this is 1.2 radian, this angle, now this angle will be 2 pi minus 1.2 radians, right? Because 2 pi radian is one complete revolution. Alright, so in the first part they ask us to show the radius of the semicircle is 5.646 centimeter. Calculate 3 decimal places. So basically they're asking us to find the radius of the semicircle. Now we can see that this is the triangle BOD and this is in fact an isosceles triangle. For example, this is 10 centimeter. This OD will also be 10 centimeter because OD and OB are the radius of this segment of this part of a circle, which is DAB. So moving on to part 1, we can see that this is B, this is O, and this is B, this is D, and here is our semicircle. Alright, and this is 1.2 radian. 1.2 radian, this is 10. And so is this. Alright, so like I told you, this OBD is an isosceles triangle. So if I draw a line from O, from this O vertex to the base, which is BD, this line will intersect the base at 90 degrees and will be at the midpoint of the base. This part will be equal to this part. So all I need to do is to find this part, which will be equal to the radius of the semicircle. So let's mark this point as M. I need to find MB. So for that I'll use sine, and this line, it also bisects the angle. So this will be 0.6 radian, and so will be this 0.6 radian. Alright, so if I do sine of 0.6 equals to R by 10, so R will be equals to 10 into sine 0.6. Hence R gets equal to, if we compute this, we get R 5.646 centimeter. Alright, this is 5.646 centimeter. So we have shown that the radius of the semicircle is 5.646 centimeter. Now moving on to part 2. Part 2, it says to find the perimeter of the metal plate. So now perimeter is basically the sum of all sides. Perimeter is the sum of all sides. Right? So if we look at the figure, to find the perimeter, I need to find the arc length DAB, and I'll have to add this arc length into the circumference of the semicircle, which is BCD. So I'll write arc length PAD plus added to circumference of semicircle BCD. So arc length of BAD, the formula for the arc length, if the angle is in radians, is r theta plus this will be 2 pi r over 2. Right? This is circumference of a complete circle, and circumference of a semicircle is 2 pi r divided by 2. So r theta, r is 10. Now theta is this one, 2 pi minus 1.2, because we're taking the arc length of DAB. We're not taking the arc length which is right here, BD, but we're taking the arc length of DAB. So I'll use this angle, 2 pi minus 1.2. 10 into 2 pi minus 1.2 plus 2 into pi, r was 5.646 over 2. If we compute this, we get 68.6 centimeter. Right? Now moving on to part 3. In part 3, it says to find the area of the metal plate. Now, to find the area of the metal plate, I'll have to find the area of the segment BAB, add it with the area of the triangle BOD, and then add it with the area of the semicircle BCD. So if I write it all down, area is area of metal plate is area of segment BAD plus area of triangle was DOB plus area of semicircle, this a circle, symbol of circle, BCD. So area of segment BAD will be half r squared theta. R is 10 right here, and angle theta is 2 pi minus 1.2. Half r squared theta plus area of triangle DOB. I'll use this formula, half into side 1 into side 2 into the sine of the angle between them, plus area of semicircle. So area of circle is pi r square, area of semicircle will be pi r square divided by 2. So if we plug in the values, r is 10 squared, theta is 2 pi minus 1.2 plus the area of triangle, half into side 1 is 10, side 2 is 10, as you can see here. This is side 1, this is side 2, and this is the angle between the two sides. Side 1, side 2 into angle, sine the angle between them, which is 1.2, plus pi r squared, r was 5.646 of the semicircle, over 2. Now be sure to put your calculator into radian mode before solving this, because here the angle is being taken as in radians, and this formula, half r squared theta, and the formula for finding the arc length, which is r theta, is only applicable for when the angle is in radians. So if I compute this, I'll get 350.83 centimeter squared.